Now, as part of the series, we have been dealing with the deployment, and we did cover certain deployment things. We discussed about the local deployment using Flask, which is the most happening. And for me personally, I have used it a lot. So I feel more confident in Flask. It's kind of simple, readily available templates, and majority of the community using that. Then we talked about Heroku platform, which is a very, very interesting and readily available platform for deploying the ML models. Then we also talked about the GitHub repository. We talked about FastAPI, right? These are some of the platforms that we have talked about. Now, I hope you guys are practicing. There are many such platforms which are being made available for the data science community for easy deployment. Because as a data scientist, you're not just expected to develop a machine learning algorithm, but the algorithm has to be scalable. It has to be working for new data at the same level that it was working on the historical data. So for that, we need to come up with the entire framework, the CRISP-MLQ workflow that we try to implement in such a way that it is scalable. That is, after deployment also, it continues to do that, what basically is expected by a model. And your clients should be able to consume it for certain duration in the future. And that's what CRISP-MLQ is all about. And that is what was lacking in the previous approaches, which probably we call it as CRISP-DM. Now, in order to ensure that we develop and deploy the solution and monitor and maintain it, we need to ensure that continuous training is implemented, continuous integration and continuous development. That is the key. CI/CD is the terminology that we talk about for productionizing any solution. Now, as part of this series, we basically have tried to learn certain tools, right? Let me just bring up those on the screen once again. So we talked about Flask. We talked about FastAPI. We talked about Heroku. We talked about Docker. Till now, right? In the series of 3 sessions, this is the 4th session. These are the things that we try to explore. The machine learning models that we develop, they are very, very, very strongly depending on the data that we are passing for training. Ultimately, an ML model is trying to explain about the relationship between the factors that we have in our data. Saying that, in order to deploy, right, I've specifically written these two separately. In order to ensure that we deploy a solution, now what does a deployment actually means? Think, I'll give you a 5 seconds pause. When we say deploy an application, an ML app, what does that actually mean? Right? So deploying basically means whatever the code, I'll assume that we are creating a Python code. It could be a .py or IPYNB file, right? These two files, standard files that we use for generating your machine learning code. So this code has to be used in businesses. Now, we are not going to use it, right? As a data scientist, I'll be developing the application. But ultimately, that application has to be used by the client and probably their customers, a business and their customers. Now, we do not expect the customers to use a code. And this code has to be readily working always for the business, right? So hence, we need a front end. In the back end, you could have a database, you could have, right, whatever the data source that we have, but the ML engine should basically project an interface for the end users, which can allow them to very easily use that functionality. An ML app, when we say, it gives us some functionality, right? So end users should be able to use that functionality. For that, we need a front end. Now, generally, when we say a front end, this is the architecture. Let me just again bring it up. So as an end user, the end user would like to have a kind of a HTML front end. And this is your front end. This is our customer. My handwriting is poor. Please bear with me on that. For an end user, it does not matter what applications or what software we are using, isn't it? They will feed in their input and they need results. That's all. So for creating this HTML, we are assuming that we are going to create a very simple HTML view, HTML pages. For creating this HTML web pages, frameworks are used. We are using Python, so it allows us to create these frameworks. As part of this web frameworks, we used Flask, my favorite, FastAPI, which is specifically designed for your ML related applications, and it is considered to be super fast. It is growing. But these are also considered to be very small. In fact, Flask has another name called as micro web framework, right? So these are very, very small frameworks, and they are readily containing a lot of templates. A lot of things are easily made available for us. Everything is pre-written kind of a thing. But if you need more customization, if you want to have a very large application you want to develop, then you need a full stack web framework, right? And the third framework that we are going to cover now is called as Django. This is the third framework, right? So we will be talking about this Django today, and we'll understand how we can generate a HTML view for our machine learning models. Post that, once your machine learning code and your front end, right, web framework API are ready, this becomes our entire code. Right? This has the best ML model, and top of that, we will create the web framework. Together, everything can be deposited into a code repository. There itself, you can try and update your code, and a centralized hub where all the people contribute in developing our application. So we might have data analysts, we might have data scientists, we might have specific forecasting team or machine learning experts, data cleaning team, the web UI development team. So there may be multiple team members for developing each of the branch that is required for our entire application to work without any issues. So we will have this centralized location where all the team members are projecting their or updating their work. Hence, it becomes your code repository, centralized hub. Once your code is ready, then from here, you will be able to deploy that on either your local on-site local host or on-premise server, or you can use any of your cloud-based platforms. This is basically, we have tried on local host, and this is Heroku. We will be covering other platforms also as part of the series of these discussions that we are going to have. We will be covering a lot of other tools. Streamlit is one such tool. I'm getting a lot of requests for that. We will have that session in the next weekend. Over the next weekend, Streamlit would be something that we will be targeting next. And post that, we also have cloud platforms like Azure, AWS, GCP, the most popular cloud platforms. So we are going to try and deposit all this code on a server so that it creates an endpoint which can be used by the end users. All right, so that is the entire overview. If you are not clear on what does model deployment means, this is what we are trying to do. So we have code, we have web framework related code, which basically gives you a HTML view. Together, all these things are basically pushed onto your end server, right? Which basically is used to host the final software. That would give us the endpoint, right? The API, which can allow us to connect with the ML code. And then we will be able to use the functionality of your model.